we're finishing up 6-1. We got to here. We do have a word problem. There are a lot of word problems this semester. Remember that we've talked about how to approach word problems. Number one, read it multiple times. You cannot read it one time and expect to run with it correctly and get it right. Like, read it multiple times. Mark out what you don't need. Draw a picture. And y'all's picture's already drawn because I forgot to hide it. This was supposed to be hidden, but anyways, let's look at it. A window washing crew has purchased a new 30-foot extension ladder. The manufacturer states that the safest placement on a wall is to extend the ladder to 25 feet and to position the base 6.5 feet from the wall. We don't care what our source is on ladder validity. What angle does the ladder make with the ground in this position? As you're reading these word problems, use clues to know how to set it up, how to approach it, what math does it involve. We've been using trig. We've been using trig ratios. We've been solving for right triangles. So you're clearly drawing a right triangle here. If this picture was not here, could you draw it?
Yes.
What information in the word problem is there to throw you off? I just realized y'all are wearing shorts. It's like 15 degrees outside. Y'all are that freezing outside. Yeah.
The 30-foot extension ladder.
Yeah, when they said that they purchased new 30-foot extension ladders, and then if you read the next sentence, it says they only want you to extend the ladder to 25 feet. So this is an element of, like, let's throw them for a loop. The ladder will extend to 30, but the problem says we're only going to extend it to 25. So you've got to pay attention to that unnecessary info. Picture a house in front of you, like this is the wall of the house, and I'm going to take a ladder, miniature court. We'll take a ladder that will extend to 30 feet, and I'm only going to extend it to 25, and the goal is to climb the ladder. So the ladder would not look like this, right? And it wouldn't look like that. That doesn't help me get to the roof of the house. It would lean against the house. 25 feet would be the ladder, and it says to position the base of the ladder 6.5 feet from the wall. Well, here's the wall, so I would measure out 6.5 feet. So that would tell me this is clearly 6.5 down here. Then it says, what angle does the ladder make with the ground? This angle, the ground's down here, the ladder is the hypotenuse, so this is the angle they're asking for. This is a basic solving for the missing angle of a right triangle problem. So we're going to use trig. Let's label what we have. We know the hypotenuse. We know the adjacent. So which trig function? Cosine. Remember the what we practiced last week and the week before. Setting up your trig equation. It's going to be the trig function, the angle measure equals fraction bar. In the fraction goes the two sides from the picture. In this case, adjacent over hypotenuse. Okay, we practiced finding the missing angle. I need theta by itself, so I do what? How do I get theta by itself?
You do 6.5 over 25 over cosine. Like cosine on both sides.
Close. You don't divide it. You apply its inverse. That -1 thing. So over here, I would would say I'm going to multiply by cosine -1. I'm going to get rid of it. Those undo each other. And then technically you'd come over here and do it. I like to just come down to the next line because it has to go in front of that. 6.5 over 25. Theta would come down, and that's what you would type in the calculator. So if you look how I lined it up, the cosine just shifts to the other side, but you do have the little -1, and that's because this is the inverse. Here's what I want you to remember. Use inverse trig for inside the triangle. Use inverse trig when you're finding the angle inside the triangle. Inverse inside. Okay? And then make sure your calculators are in degree mode, by the way. Yeah. Right one? Here.
I got
Did you get 74.9 degrees? Or you could say 75. Either way. I did both. Okay, what if it's not a picture with the sides labeled? What if I'm telling you that the sine of theta is this decimal? Can you tell me the angle measure? This is what I had to do in high school. We used trig tables. It was awful. We had to go to the back of the textbook and find on the trig table that decimal and then like cross-reference it to get the angle measure. We did have calculators. It's just she wanted us to use the trig tables.
do I have all the answers?
Miss Holcombe.
Well, I was about to say
answers.
Why are the answer key?
He's trying to get locked in.
I don't know.
This is cheating.
I'll give you a blank one. Hold on. Riles said something over the weekend I have to share because I wanted to choke him. Hold on. Well, it was something in the house. It was a toy maybe? Or something. Now I can't remember. But anyways, he came up with this question. He goes, did they have batteries when you were a kid? And I'm like, did they have batteries when I was... Yes, son. And he said, when were you born? And I told him, he goes, oh, I guess they did. And I'm like, I'm not from the colonial times. We had electricity, running water, heat, air. I went, oh, bless his heart. Okay. So this is asking, can you find the theta measure when it's a decimal? This is the same. Let me put it in context for you. I'm going to change colors. I'll go to this. Come over here. Somebody take your calculator and just tell me what 6.5 divided by 25 is.
0.26.
That's it? There's no more?
That's literally
That's
it.
all right. Okay, so it would be the same thing as if this had been the problem to start with.
Oh, so all we do is
It's the
just,
same thing.
okay.
So you're still finding theta by moving this to the other side by inverse, and instead of having a fraction, you have that ugly decimal. So you will type the full decimal. Let's go to the nearest 10th on all three of these. Don't be scared of the decimal. Don't make that think you. Don't let that confuse you. 30.8. Did I do it wrong?
I got 30.8.
I got 30.8.
You're ready to go. I was like, how did you get?
Okay. Okay, the last two slides are teaching us a relationship between co-function identities. There's a pattern. You learned this for probably 10 minutes in geometry 3 years ago, 2 years ago. So you may not remember it. So let's look at this. When two angles are complementary, do you remember what that means they do? There you go. Complementary means angle plus angle equals 90 degrees. You will notice that every time you have a right triangle, we talked about this, the two acute angles always have to add to 90 because the right angle is also 90 and it maxes out at 180. There's a relationship between the two acute angles and their co-function identities. Now, to help you spot the relationship, all 6 trig functions of 37 have been laid out. All 6 trig functions of 53 have been laid out. Take a second and look. See if you see the pattern. Or what do you notice? Look at all of these answers. Something should stick out. What? You notice a few of them match? Let's just highlight a couple, because if we highlighted all of them, the whole thing would be highlighted. Where else do you see 0.6018? Okay. Where else do you see 0.7986? Where else do you see, I need another color. Where else do you see 1.3270? Okay. All right, so now look. The sine of 37, watch what I highlight. The sine of 37, opposite over hypotenuse, is the same decimal value as the cosine of 53. Cosine of 53 would be adjacent over hypotenuse. The sine of one angle uses the same sides as the cosine of the other angle. Tangent. The tangent of 37, opposite over adjacent. The cotan of, I said that backwards. The cotan of 53 would be adjacent over opposite. Again, same sides, same formula. So the takeaway from this slide, what's the point of the slide? The point is that sometimes if I tell you the sine of 37, then I've also secretly told you the cosine of 53. If I give you the cotan of 37, then I've also given you the tan of 53. Okay? What notes do we take on here? Look right here and make a note that if you need a refresher on complementary angles, write that up there. Co-function identities down here. you will notice this looks very complicated. This is just where they're saying whatever theta is, subtract it off of 90 to get the other acute angle, which you already know that because we know that the angles of a triangle add up to 180. We know that the corner is always 90, and we know the other two have to add to 90. This is just a fancy way of writing it, okay? Let's practice it. Go to this slide. It says, given that sine of 18 degrees is the decimal 0.3090, and cosine of 18 degrees is 0.9511, and tangent of 18 degrees is 0.3249, it says find the other 6 trig functions of 72. So what happened? What did it switch to? It's changed to the 72 angle. If you need to draw a picture just to kind of wrap your mind around it, you can. You got one angle that's 18 and you got the other angle that's 72. They want the 6 trig function values of 72 degrees. So I'm going to lay it out. I got sine 72, cosine 72, tangent. Sine starts with an S, so the reciprocal would be cosecant, secant, cotan. Now I spaced them out really big because one, I didn't want it to get crowded, and two, we do have a little bit of work to do when we get to the reciprocal, some of the reciprocal functions. Okay, here's what you need to remember. The sine of one angle will equal the cosine of the other. The cosine of one angle will equal the sine of the other. The tangent of one angle will equal the cotan of the other. Okay? So, sine of 72, they give me these values up here, which, okay, actually, just for my, you don't have to do this, but I'm going to write it over here. This is bothering me. Okay. So 18. Alright. So now I don't have to look in the directions and read it and mess up possibly. Okay. Sine 72 would be equal to which one? Cosine 18, right? So I'm going to make a note, cosine 18, and then I'm going to write that decimal. Cosine 72 would be equal to sine 18. Okay, tan 72 would be equal to cotan 18. They did not give me cotan 18. Stay with me, Brody. They didn't give me cotan 18, but think back to what we did on Friday when we were trying to evaluate those reciprocal functions in the calculator. There's no cotan button. We rewrote it as the reciprocal 1 over tan. There you go. So I can rewrite this as 1 over tan 18 because I do know tan 18 is that decimal. So now I can say that's 1 over 0.3249, and then I could type that in my calculator. 1 divide 0.3249. So quick.
Oh my God, I got a calculator right here.
You also have the answer key. Yeah. You'll notice that I usually follow the trend of the problem. If the problem's to 4 places, then I go to 4. All right, now let's go to cosecant 72. If cosecant 72 is hard for you to wrap your mind around, because that's not one of the cofunctions we talked about on the other slide, then rewrite it as the reciprocal in terms of 1 over, cosecant is 1 over sine. So this is 1 over sine 72, right? And what is sine 72? 0.9511, because we found it right here. So this is where you're using that previous, so 1 over 0.9511, and you would type that in your calculator to get the answer. .0515. Is that what you got, Brody? You got what? Did I do it wrong? Did I? Whatever. Yeah, Luke's wrong. 4. I'll have to change that again. Secant 72. I could rewrite that how? 1 over cosine 72, right? And do I know cosine 72?
Yeah.
Yeah, I just found it earlier. Now you don't have as much work to do on the next one, so don't overthink it. The cotan of one angle will equal the tan of the other. So this will equal the tan of 18. Do I know tan 18? Yeah, they gave it to me. So we have less work on that one. So which ones do you actually need to memorize? Like, you know, the sine of this one is the cosine of that one. I'm going to put a green dot next to the ones that came from memory or the co-function identities, I guess. Let me say that. They came from the co-function identities. The other 3 came from writing the reciprocal and then using the value we already found. We didn't have any actual like co-function, like the tan of 72 did equal the cotan of 18, but then to come right here, I had to write cotan in terms of the reciprocal to get the answer. You'll notice the ones I highlighted in green were shorter, and that was because it was that co-function identity. That's it for 6-1. I do have a copy of number 20 and 21 for some reason to talk to you about in the homework. I'm not sure. Let me look. So number 20 asks you to evaluate let me write it bigger. If cotan of theta is 1.138, it says what is the measure of theta? To evaluate this, you need theta by itself. Cotan's got to go to the other side, right? Cotan inverse. But you don't have a cotan inverse button on your calculator. You would have to write cotan as 1 over tan. That's why I think I put this in on the notes to say, hey, heads up when you get here. We practiced this on Friday. You would do 1 over tan inverse because you're still finding the angle. And then here it did secant, so I would end up using 1 over cosine inverse. You have quite a few homework problems. You should have already started it. You should not be starting from number 1. I'm going to go in and look and see if any of them need to be removed. There will be quite a few that get removed throughout the semester because they just kind of go off on the deep end more than what we need.